Okay, week 3, day 2. I'm going to remind you again, if you have not seen it already, I am not going to have a live session Thursday during week 3. It will be Friday during week 3. During your block, I moved it to Friday, so that way I had one more available time if you had questions before you want to take your quiz. If you don't need to come to those Q&A sessions, just a reminder that you need to at least do the daily attendance question. Okay? So here we go, week 3, day 2. We are still solving radical equations. Okay? So solving radical equations, part 2. Last time was a little bit long. I promise this time, although the questions take a little bit longer, it will be a shorter video. Okay? So what we're going to do first, after you get everything started and going here, is I want you to complete this question right here. The only nice hint I'm going to give you here is that although we didn't do one exactly like this in our notes last time, you can move radicals to another side of the equation just the same as you can move a variable or you can move a constant, okay? So I can, to make this a lot easier on myself, move this cube root of 8x plus 1 to the other side by adding it. And then the only thing that's different about this one compared to the last question that was on our notes from last time is that these are cube roots instead of square roots, but does that really change the question is what I'm going to ask you. So I want you to pause this and solve it from here. Alright, the answer to that was no. The solving does not change just because it's a cube root instead of a square root. I can cube root both sides and then just simply solve for the variable from there. Okay, so here I got an answer of 4 over 6, which I reduced to 2 over 3. I still need to check my answer. Okay, just because it's a fraction does not change anything. So, if I could type or write correctly here, cube root of 2 times 2/3 plus 5 minus, now notice I'm going back to the original, 8 times 2/3 plus 1 equals 0. Okay, when I check this, 2 times 2/3 right here. Okay, 2 times 2/3 is 4 over 3. Then I'm going to add a 5 here in a little bit. And I'm also going to, well, I don't know why I put an equals there. There we go. I'm also going to do the 8 times 2/3 to get 16 over 3 here. Plus 1 equals 0. If I'm going to add these, I need to have a common denominator. Okay, so the cube root of 4/3 plus 5, if I want to put it over 3, becomes 15/3 minus the cube root of 16 over 3, 1 becomes 3 over 3. And although this looks nice and ugly right now, when I go to this next step, 4 plus 15, because they have a common denominator, is 19/3. I don't know why I made that so large there. Let's see if I can, oh. There we go. Minus the cube root of 16 plus 3 is also 19/3. Well, if those are exactly the same here, cube root of 19/3 minus cube root of 19/3, I'm going to end up with 0 equals 0. So that tells me for sure 2/3 is an answer. Alright, so here's what's different about today's questions. I have 2 radicals in my equation. The difference here is that 2 plus the square root of x is not under one big square root. Okay, so I'll give you a moment to write the question. When that 2 plus square root of x right there, some of you are thinking, oh, just isolate the square root. It's not going to work quite the same as it did the other day in the first lesson. So here we go. We already have an isolated square root. This square root is isolated. There is no way I can isolate the second one at this moment in time. Alright, so because that first one is isolated, we can actually go ahead and square both sides. Now, on the left, that's nice and easy. Whew, it's done. Okay, so I have x plus 1. On the right, remember squared means write it twice. Okay, so that means I'm going to write this twice. 2 plus the square root of x times 2 plus the square root of x. If I can write correctly, there we go. Okay, Now I'm going to try to color code this the best I can. On the left, I'm going to keep that x plus 1. Okay, on the right, I am going to distribute. Okay, 2 times 2 is 4. Then I am going to do 2 times the square root of x, which is 2 square root of x. Then I am going to now distribute the square root of x. Square root of x times 2 is also 2 square root of x. And then finally, I am going to distribute the square root of x times square root of x. Okay, that becomes, multiply the outsides, 1 times 1 is 1. Multiply the insides, x times x, x squared. Okay, so now I'm going to go through and I'm going to simplify this the best I can. I have x plus 1 on the left still. On the right, this 2 square root of x and 2 square root of x, they're a like term here. Okay, so 4 plus 4 square root of x. And then even better, this square root of x squared is just plus x because I can simplify that. Okay, now if you look at this entire question, it looks ugly, I get it. Okay, but if you look at this entire question, I have only one square root left. Okay, I now want to get that square root by itself. Okay, so to do that, first, I'm going to go ahead and subtract the 4. And at the same time, you can go ahead and subtract the x, because they're not attached to each other, they're not attached to anything. Okay, so I'm just isolating right now, in this case, this entire term, the 4 square root of x. Okay, you can do those in 2 separate steps. I chose them to do them in one here. So now I have this. Well, x minus x is 0. Perfect. 1 minus 4 is negative 3 equals 4 square root of x. Because remember, those are gone and that is gone. Okay, now I'm trying to isolate that square root. Okay, so I can divide by 4. And now, although this looks ugly right here, negative 3 over 4 equals the square root of x. I don't even have to continue. Okay, we talked about this on the last set of notes here, that, hey, a square root cannot ever equal a negative number. Okay, so a square root of just an x cannot ever equal a negative number. So I can actually, on this specific question, stop right here if I want to and say no solution. Okay, it is not going to work. That square root of x cannot equal a negative. Now, if I were to continue, I would square both sides and end up with a lovely fraction that I would have to put back up there and check. And it still would not equal in my check as well. Okay, but I can stop right here because, hey, a square root of x cannot equal a negative, so I'm done. All right, now, not every question is going to end that way. All right, so here's the second one. I want you to try to at least start this here on your own and see how far you can get before you have to unpause and check with me. Alright, so what I'm going to do here is I'm going to move this screen shape down as I went through each step. So you pause and play as you're checking yourself on each step, or if you've done the entire question, you can play the whole thing here. The idea here is I want you to try a step on your own, check yourself. Try a step on your own and check yourself. Okay, so first, obviously, I squared both sides. On the right, yes, that's going to end up with the square root of x minus 7 squared being x minus 7. On the left, I wrote it twice. When you distribute on the left, again, I tried to color code there for you. That is what you should end up with. When you simplify on the left, combine anything that's the same, square root anything, that's what you should end up with. I then subtracted the 49 and subtracted the x. So that I have negative 14 square root of x equals negative 56. This is not like the previous question. Right now, I cannot say, oh, no solution equals negative, because my square root's not by itself. When I divide by that negative 14, we end up getting, hey, square root of x equals a positive, which means I can continue. Get rid of the square root by squaring. Okay. And I end up with x equals 16. All I have left to do here is check my answer to see if it works. Okay, so I want you to pause and check, meaning 7 minus the square root of 16 equals square root of 16 and then minus 7. Alright, so I get that yes, it indeed works. So guess what? 16 is my only answer for that question. Alright, that is all I have for today. So make sure if you have questions, you are popping in during the Q&A sessions. Thank you.